First, let me tell you a little bit about me and my academic background. My name is Mainland. Got my bachelor's degree, my master's degree from U of H. I'm a PhD student at Rice and U of H. My field is abstract algebra and mathematics. Some people teach the subject, and some people live the subject. I'm the latter, which means 24 hours a day I do mathematics. It doesn't matter if I'm here or not. First thing I'm going to do is I'm going to give you my email, which is going to be helpful to you. Because if you're trying to work one of those problems and you're having difficulty, that's what you're going to do. You can scan what you have done, send it to me, and I will comment on it and I'll send it back to you. Anytime you want to email me, that's fine. This is a Yahoo email. It is not case sensitive, so that's fine. We can just start with number 1, for example. The first thing I want to tell you about the answer, right? There are 3 levels of mathematical learning. 1, listening. 2nd, seeing. Both are very important. The most important one, and the one we are not doing enough of, is working out what? Problems. And I can see a lot when somebody comes to the math tutoring lab. What do they ask you? How do we do number 6? That's the wrong question. What you should be asking is, what is the concept involved in number 6? And you see, this exam, you see a lot, I focus on the concept versus, this is how we do this problem. I know how to do this problem. The idea is to teach you how to do the problem, not to teach me how to do the problem. So let's begin with number 1, for example. Negative 1/5, x equal to 4 over 5. What's the idea here? Somebody tell me how to begin. What would you want to do?
You want to isolate that.
That's right, you want to isolate that. But I know a lot of you don't like what?
Fractions.
Fractions. You see fractions, you almost want to call 911. You don't like that stuff. But remember, fractions are just like any regular numbers. In mathematics, we have 4 operations: multiplication, division, addition, and subtraction. If you don't like one operation, you can cancel it. If I don't like multiplication, how do I cancel that? And if I don't like division, how do I cancel that? So we are dividing by what? By 5. And how do I cancel division? I'm going to go ahead and do what? Multiply the left side by what? And the right side by what also? 5. Because that is an equality. You can't do something to the left side without doing the exact same to the left, to the what? Now how is that going to help me? Because 5 and 5 are going to do what?
Cancel.
And then 5 and 5 are going to do what?
Cancel.
So what is the result? Negative x is equal to what? 4. Am I done over here?
No.
I'm not looking for negative x, right? What am I looking for? X. So how are you going to do that now? How are you going to get that x? Divide by what? Because this negative actually is nothing but negative 1 multiplying what? X. Let's go ahead and do that division. Now, this is going to cancel out, and x is equal to what? Negative what? 4. Okay. You see the idea here? And you see the mathematical operations step by step, right? Just go ahead and try. Any equipment. All right. Now, when you work on your final exam, I want to give you 2 advice. It's never recommended in mathematics that somebody works horizontally. It's not a good idea. Because you can't follow each step. You want to work the problem step by step. So if you make a mistake, for example, on this step, you know how to go back and correct that single mistake. You don't have to go back and correct the whole problem. And math is like a chess game. Always you ask yourself this question: what's my next move? What is my next idea? For example, and right here, what did you do? You canceled what? 5, right? Okay? That's your idea. Right here, what did you do? Cancel the multiplication by negative what? See, each step reflects one idea. One thing you needed to do in the problem. And no matter how complicated the problem, the strategy is the same. Step by what? Step. Are we clear on number one?
Yes.
Okay. Shall I erase that? That's okay now? Okay. Number two is the same thing. What I want you to do is first try number two on your own. Okay, let's write the problem. Before you tell me how you did it, I want to know what is it that you're doing, right? 1 over 5 times x plus 6 equal 1 over 6 times x plus what?
8.
All right. Now, how is this problem different from the problem before, from the previous problem? So actually, your job got a little bit complicated because now you have to clear what? 5, and then you have to clear what? 6. So you want to come up with that number that can clear 5 and can clear what?
30.
So what is that number?
30.
Okay, well, that's good. That's more. That's me. Doesn't matter if you have cameras or not. That never changed. All right. How is that going to help? Now let's pay attention. I want to remind you of something. What's the answer when you write something like this? 12 times 3 over 4. Okay? One more time. What is it that you are doing? We are multiplying by 3, dividing by what?
4.
Or dividing by 4, and then multiplying by what?
30.
Remember, division and multiplication carry the same priority. We don't care which one you do first. What? 12 divided by 4 is what?
3.
Times 3 is what?
9.
12 times 3 is what? Divided by 4 is what?
9.
Up to you. But we always multiply by the numerator, divide by the what? Denominator. See, once you know the rules, fraction become your best friend. Now, we are multiplying by 1, right? And dividing by what?
5.
Okay, so what is 30 divided by 5?
6.
Okay, 6 times x plus what? Equal? 30 divided by 6 is what? 5 times what? X plus what? 8. Well, that's just x. Now this is much better, right? This is a cleaner version of this, right? Now what? Go ahead.
I thought that
Go ahead.
whatever you did to one side, okay, we did the 30, that you also had to multiply the 30 times the x plus the 6. Am I jumping too far ahead? That's what I was taught. That if you're multiplying the 1/5 by 30, you have to do the x plus 6 by 30 as well, and then the other half of it.
Okay. Let me put your mind at ease, okay?
Please do.
The parentheses just signify that this is one number.
Okay.
Only one. You have this 30, right?
Mhm.
It's going to multiply 1/5.
Right.
Also, you have 3 numbers multiplying each other, right? Now, imagine you have those. 3 times 2 times 4. You certainly don't do this. You don't multiply 3 times 2 and then 3 times what? 4.
Right.
What you do is you multiply 2 of them, right? 3 times 2 is what?
6.
Times 4.
24.
Well, that's the same principle.
Okay.
You see the idea? All the parentheses mean that you want to treat this as one single entity, one single number. Now, after you have done this, it's time for us
Okay.
to get rid of the parentheses.
Right.
But the parentheses mean which mathematical operation? Multiplication, right?
Right.
So this is going to be what?
6x plus 36.
And plus what?
36.
That's right. Equal to what?
5x plus 40.
5x plus what?
40.
40. So almost there. Now what?
Okay.
Now what are you going to do?
Now you're going to collect your
Combine like terms.
terms.
I just love when people say stuff like that. She said, I'm going to combine like terms. I like it. But how are you going to combine like terms?
Well, actually, Take the 36 from the 4.
You need those terms to be on the same side, right? So this 5x is going to move to the left, right?
Right.
And it's going to become negative 5 what?
X.
And this positive 36 is going to become what?
Negative 36.
Okay. Now pay attention. Did you notice how when I circle the number, I always circle the sign before that number? That's very important, right? We are adding 36 on the left side. When that was transposed to the right side, it became negative what?
36.
Now I can go ahead and do exactly what she wanted to do, which is to combine like terms. What is 6x minus 5x?
X.
X. And what is 40 minus 36?
4.
4, right? That's your final what?
Answer.
Of course, you can go back and verify, right? And check, and it will work in the original equation. For example, 4 plus 6 is what? 10, right? But 10 times 1/5, that's the same thing as divided by what? 5, which is 2, right? Well, let's see this side. 4 plus 8 is what?
12.
Divided by 6 is what?
2.
Voila. That's how mathematics work, right?
That's much easier.
But don't worry too much about the answer. If you know the concept, if you do step by step, the right answer is gonna be there for you. Is that so? You understand that they might give you a problem where you need to clear the fraction, and they might give you a problem where you are responsible to clear, for example, two different numbers, like 5 and what?
6.
6. Okay?
Okay.
In
Yep.
this case, you do the LCM, right? Least common multiple.
Excuse me.
Yes.
She needs a sheet.
Also, you need the exam and all that stuff, right? Yeah, go ahead. What I'm going to do, I'm going to put all this over here. So, this is your answer key. I just love those answer keys. They are so neat. All right.
That makes much more sense because the way I was doing it was multiplying everything by 30 or whatever the LCM was.
Yep,
I was making it
yeah.
harder on myself because that's what I was taught. Okay, so much easier.
We don't talk about previous experience.
I'm trying to get it out of my brain.
You're right. Now we have to deal with word problems. Don't you all love word problems? And maybe we leave word problems till the end. I'll deal with all of them. Don't. Shall we erase all this now? That's okay. Let's try to do number 4. What I'm going to try to do, isn't it a miracle that I always pick up the marker that doesn't work? Okay. So they're asking you to do some simplification, right? Over what? Z what?
Negative 5.
Negative 5. All right. What I want to do is, when we have a problem, I'm going to review a little bit of the concept with you, right?
Okay.
So we don't say, this is how we solve this problem, we are done. I don't think that's right. So this is involving the rules of what? Rules of what?
Exponents.
Exponent. Now remind me what those rules are. For example, if I have x2 times x3, what would I do?
You
Add
the exponent.
You would add the exponent. But the actual operation is what?
Multiplication.
Of what?
Exponent.
The variable.
You see, vocabulary is very important. And I'm about to tell you what that is. This by itself is called a power. The x is called a base. And the 2 is called what? An exponent. And if you have a number like 4x5, for example, this 4 is called a coefficient. Okay? It's very important for us to speak the same language. Right? Okay. If we multiply powers with the same base, then we must add the what?
Exponent.
You see the language? Very important. Okay. So, multiplication of powers, you add the exponent, right? Okay, what about if you have something like this? x3 over x2. Now what? Subtract what from what?
Top from the bottom.
Numerator is from the numerator. It's not your fault. It's not your fault. You've been hearing this all your life. I know.
Mhm.
It's like plugging in, which is x, right? X. I have dealt with the multiplication of power, with the division. What about when I have something like this? x3 to the 4th power. Now what do? This is a power raised to another exponent, right? Which means this is x, what? 12. Least but not last, how do you deal with negative exponent? For example, how do I deal with this? X negative 2 over x negative 3. What would you do?
You can multiply.
Doesn't she sound much more sophisticated when she said that? That is just beautiful what you said. Before when you said flip, I was confused. This is what you're going to do. You're going to change position of the base and then change the sign of the exponent. Which means this is going to become x what? This is going to become x what? And now we are back to doing what we do best, which is division. X. You see, these are the rules that govern all those problems. Now I can give you 10 different problems, but if you know the rules, you're going to do those problems the right way. What is the first thing you do when you have an exponent problem like this? What's the first thing you want to do? Change all negative exponent to what? Because it's easier for us to deal with positive exponents, right? Well, how would I do that? This is going which way?
Over to the
And this is going which way?
down
All right.
there.
Now pay attention. When you do something like that, I want you to cross. It's no longer here, okay? What is my result? In here we have x, 7, and then z what? And then in the denominator you have y what? 9. Now what? What else I can do? You say that's it. I'm not convinced. Why you say that's it? Can I not add 7 and 5?
No, because it's not the same base. It
So
just,
we have a prerequisite for all the rules, right?
right,
We must have the same what?
base,
Other than, so we can't do the operation if we have different what?
bases.
You see, this is concept versus let me help you do problem number 4. That's not good. So if I wanted to do this exam problem by problem, we just finish in half an hour. Would anybody go home? And you still have the same problem. That's not good. Shall I erase all this now? Okay. Can we erase all this now?
Yes.
Yeah, we can. After all, we do have the eraser, don't we? Okay. So, okay, let's see. Number 5 deals with the radicals, right?
Yes.
No, let's try number 6 because it deals also with exponents. Okay? So let me first go ahead and try number 6 on your own a little bit, and then let's see what we can do in number 6. Okay? All right. And remember, step by what?
Yeah.
Okay. And when do you take the final for this class?
Wednesday.
Monday, I'm going to be at the tutoring lab Monday from 5:30 to like 9 something. So if you have more questions, maybe you come and ask some of those questions, right? Okay? What's the first thing you want to do here? By the negative 2, right?
Yes.
All right. May I suggest a different approach?
Sure.
You see in this problem, right? Why don't we clean up this first, okay? Then we worry about the what? The negative. Because for the inside expression, we don't have any negative what? Exponent. So, what can we do? This is x to the first power, right? And this is x to what power?
4.
So, this is division, right? So what would that be? X to the what? What do you do when it comes to division of powers? Subtract what from what?
The numerator from the denominator.
1 minus what?
4.
Which is? One more time. 1 minus 4, which is? Okay. See, the rules don't change because we change the numbers, right? Okay. Now, this is what? This is 3 and what?
1.
So now what? This will be y what? 2. Alright. So now what do we do? Negative 2. First we're going to deal with that inside expression, right? Forget about that negative 2. We'll deal with that later. Now what? What will you do here? And then this will become x what? And this is negative what? Now what?
Now you would multiply.
Before we do that, how am I going to transform negative 2 to positive 2?
Multiply it by negative 1.
You can, but what I'm saying is, you see those one numerator, one what? How about if I do something like this? Who has the sign-in list?
Did you have the evaluation?
Yeah, I want right. Oh, yeah.
Everybody else signed it?
You see what we did here? We also changed what? Positions, right? Mm-hmm. Because
Not flip it.
we changed position also.
Change
Yeah.
position.
So now what do you have? X what? 3 times 2 is what?
6.
And then y what? It's much easier for us to deal with positive what? Exponent.
Let me know if you need a break.
Oh, no problem.
This is for y'all to fill out.
I'm trying to see if there are any more problems dealing with exponents.
You got my typo.
Number 11.
For the-
So once you flip it, it gets rid of the negative.
Thank you.
Right.
Well, I'm just going to flip it at the bottom. I see I got rid of
Not
it.
flip it, don't flip it.
It's not flip? Well, it doesn't always flip, only the negative ones flip, so we use that in my class. But yeah, if it's negative, it's going to change position. Anybody that hear Mrs. Shirey on Thursday? She says they're happy. If they're positive, they're happy, they stay there. If they're negative, they're unhappy, and they have to move.
Shall we raise this problem now?
Everybody else sign?
Let's practice. How do we transform this negative 3 to 3? What do we do? Y5 on what? X2. You know why? Maybe. Okay, look. you didn't want to do that, okay? This is 3 times what?
-3.
Which is,
-9.
okay? And this is 5 times what?
-3.
Which is negative what? Now, we can change, right?
Right.
So this will be y15 and x what?
50.
Remember, what we did before is this. Y, 5, and then x what?
3.
All to the third power, right?
Right.
This is y. What's 5 times 3?
15.
And what is 3 times 3?
9.
It's the same, right?
Right.
Mathematics, we don't care how you get the answers, right? It's the same. And, okay? In any concept in mathematics, if you need more practice on, just let me know and I will send you 10 million problems on each concept. It's very easy. Spend Christmas doing exponent. All right. So that's the concept involving exponents. Let's do a little bit of radicals, okay? Like number 5. I know a lot of you like what? Radicals. You love those radicals, right? 5a plus 3 square root 125a minus 7 square root of 45 what?
Okay.
All right. Okay, what is the operation involved here? What kind of operations do we have?
Addition.
Addition and what?
Subtraction.
Okay, and when we add and subtract different variables, different radicals, different anything, what is the principle involved here? You said it before.
They have to have.
We combine like what? But here we don't talk about terms. We say we combine like what? Radicals, right? So we know we have to combine like what?
Right.
Radicals. Well, this begs the question, what are the radicals that are considered like what radicals? For example, are those two like radicals?
Yes.
Yeah, obviously, right?
Right.
What about this? Are those two like radicals?
No. Yes.
Yeah.
Yes or no?
Yeah.
Right. Are those two like radicals?
No.
We have a problem, don't we? This is cube root of what?
5.
This is
Square
root of what?
5.
You and I are going to talk about some vocabulary. Let's see. X, and then A, and then Y. What do you call this X?
The
An index.
index.
What do we call this A? A by itself, the base. What do we call Y? The what? What do we call all this?
Radical
Right.
hand.
As you can. That's excellent. At least you don't say the thing underneath the other thing. That's
That's
good.
fine.
And what is this one? This is the radical symbol, right? Now pay attention. If you are under the impression that you are going to be good in mathematics without learning the vocabulary, somebody has been lying to you. This is very important. Have you ever felt like somebody's asking you a question and that question might as well be written in Chinese? It's because we don't focus enough on the vocabulary. Now, if I look at this expression, it looks like I have different what? Radicals.
Radicals.
Because this is the square root of 5 what?
A.
This is the square root of 125 what?
A.
And this is the square root of 45 what?
Okay.
So I might as well just give up and say I can't do anything. But we know better, don't we?
Mm-hmm.
But what do we know? We know I can do something here, right?
Yes.
What can we do with the square root of 125? 25 of what?
5.
There's a very good reason why you chose that 25, right? Because it's a perfect what?
Square.
Which simplifies to what?
5 times 5.
Excellent. Now, what about this square root of 45 over here? Can we do something?
Yes.
9 and what?
Times 5.
5. And this square root of 9 simplifies to what? 3. Okay, now let's pay attention. Let's clean up. This is 1 square root of what?
5.
5. This is 3 times what? Which is 15. What is left underneath the radical? 5 and what? 8. Okay? Minus 7 times 3 is what?
21.
Square root. What is underneath the radical right now? 5 and what?
8.
Oh yeah. Look at this. Remember, looks can be very what? Deceiving. Now you look at this expression. It looks like we can do a lot, right? Okay. What is 1 plus 15 minus 21? Well, 1 plus 15 is 16, right? 16 minus 21 is what? Negative 5 of what?
Square root of 5.
Square root of 5 what?
8.
You see that? Step by what?
Step.
Step. In a math classroom, don't ask what is the answer. What is the step? What is it that you're doing? So when they give you a similar problem like this, you know that the concept that we are talking about here is combining like what? And you know when you have like radicals, we have 3 things. Same exponent, same base, and same index. Okay? Let's talk a little bit more about what radical. How would you do this?
Multiply the index, I'm sorry, no, multiply the
3 and what?
2,
Which is?
6.
And then what else?
Then you multiply the radical, the
Which is?
5 is 35.
Okay. Now pay attention. Never confuse the number outside with what?
Inside.
There are rules to get inside and rules to do what?
Outside.
You don't just confuse them. You don't just say, well, this is 3 times what? That's a classic mistake. Especially when we talk about distribution, distributive property. Okay? I don't know if this is on the test or not, but I feel like you should know it, so I'm going to write it down. Go ahead. How do you do this?
Multiply the square root of 2 by 2 square root of 3.
How does this term multiply this term? 3 times what?
2.
Which is?
6.
And then
Square
square
root
root.
6.
2 times 3.
6.
And then how does this multiply this?
So it's 3 times 4.
Negative what?
Negative 12.
12. And then square root of what?
10.
10. When it comes to radicals, be careful, okay? Don't mix outside with what?
Inside.
They don't mix. There are rules to get inside and rules to do what? Okay. Let's see if any other problems involve radicals. Okay? Yeah, we have, for example, number 11, they are asking you to simplify some radicals. We'll talk about that in a minute. Maybe that's what we'll do next, okay? I'd like to go by concept than by number 1, 2, 3, 4. I think that's a little bit better. Okay? Shall we erase this? Now, if they give you the question like that on the final, you'll be able to do it, right?
Yes.
Also pay attention. I'm going to say something to you, and I want you to translate in mathematics. I almost won the lottery. You are still broke. What does that mean? A lot of you, when you do the final, man, if I only got 2 more questions right, I bet. But you did it. Be very careful. Those careless mistakes can be a killer. Well, I did everything right, but I forgot that this is what
Negative.
Well, no, you did not do everything right, and your grade is still 0. We do not have room for error. That's the problem, especially on the final, because it's multiple what?
Choice.
You know, it's just a scant on money, right? So be very, very what? Careful. Okay. Now let's talk about simplification. For example, in number 11, he wanted you to simplify the form. Square root of 64, x10, y, and then z what? 5. Okay? What would you do here? It's a perfect square, isn't it?
Yes.
So let's say this from the outset of this problem, from the beginning. Pay attention. Your final answer, more than likely, is going to have 2 components. One outside the radical and one what?
Inside.
So what I'm going to do is, from the very beginning, I'm going to do this. I'm going to put, for my final answer, all the ones inside the radicals over here, all the ones outside where? No. Now you're saying this is square root of 64, right?
Right.
And then square root of x10, y, and then z what? 5. And you notice that the square root of 64 is what? 8. So is this going outside or inside?
Outside.
So I'm going to put it where? Outside. I'm done with this one. What else can I do? She's good. She said, I know the rules. I know how this exponent goes outside. That exponent is going to divide the what? Index. You see, one more time, the importance of vocabulary. We speak the same language, you and I. The language of mathematics, right? And then she said, this is square root of x10, but this is going to be x. 10 divided by 2 is what? 5. Now, is this outside or inside?
Outside.
So I'm going to put it outside. X what? 5. I still have to deal with what? With the square root of y, and then the square root of z what?
5.
5. So let me ask you a question. Y, is that divisible by 2?
No.
You leave it where?
Inside.
Okay. Well, we dealt with this one. What do I have? I still have to deal with what now?
Z5.
Well,
But you can take one of the z's and make it z4 and then divide it by 2, so it would be z2 with the z underneath.
I couldn't explain it better myself. So that's exactly what we're going to do. Thank you for saving us time. And then, z2 and then what?
Z.
Right.
So,
That is just beautiful. Almost romantic the way she explained that stuff.
I don't know about that, but okay.
She said z4 and then z, right?
Yes.
And then this z4
Divided by 2.
divided by 2 becomes z what? Every time they tell you to simplify, more than likely your answer is going to have 2 components. One that is going to be outside the radicals, and one is going to be what? Inside. And then you try to do the problem step by what? Step by step. Mathematics can be a lot of fun. It really can. I think it's a divine subject.
That's when it gets explained with the simple explanations instead of complicated ones. It's easier. Sorry. I'm trying to let go.
One more problem, for example, that involves radical is number 20. I'm going to give you about less than 10 seconds for you to tell me what number 20 is. I'll be very surprised if
3 over 4.
number 20, which is square root of 9 over what?
16.
16.
3/4.
Square root of 9 over what? Square root of what?
16.
Which is?
3 over
3 over what? 4. Now remember, we can join and separate the radicals using multiplication and what? Division. We cannot do that using addition and what?
Subtraction.
It doesn't work. For example, square root of 1 plus square root of 4 is definitely not square root of 1 plus 4.
No.
What is the square root of 1?
1,
And what is the square root of 4?
2.
1 plus 2 is what?
3.
But this is square root of 9, right?
Yes.
What is the square root? This is square root of what? If you believe those two are the same, this means you believe 5 is the same as what?
9.
Now we have different issues. We just separate and multiply. Separate and join the radicals using multiplication or what? Division. Don't forget that. That is why you were able to write this as square root of 9 divided by square root of what? 16. Okay? It's a simple problem. Should be a bonus problem if they give you something like that. Right? Is that enough about the radical? I think so. Now what else? What else? Okay? Oh no, turns out we just met night. Let's do problem number 21, which is x equals 5 plus square root of what? 3x minus what?
5.
Is that? So first I'm going to help you out a little bit on your final exam, but we try not to tell anybody, well, since they are filming us, everybody's going to know this trick. And we are in trouble. It's okay. Okay. Let's pay attention, okay? Anytime, this is a test-taking strategy for a multiple choice exam. Anytime they give you an equation and they give you the answers, it's a bonus question. Say what? Because you really don't have to solve. I'm going to do the solving. All you have to do is use backward what? Substitution, or what you call plugging. Let's see if 10 works, right? 3 times 10 is what?
30.
Minus 5.
25.
Square root of 25 is what?
5.
Plus 5.
10.
But this is 10, right? 10 is equal to what? 10. So 10 works, right? Let's see if what? 3 works. 3 times 3 is what?
9.
What we're saying is this is 3 and this is what? 3 times what?
9.
We just want to verify, right? 3 times 3 is what?
9.
Minus 5.
4.
Oh, square root of 4 is what?
2.
Plus 5. 7 is
3.
not equal to what? 3. So this one definitely does not work, right?
Right.
Well, I mean, let's see if 5 works, right? So I'm going to change this to what?
5.
5. Okay? 3 times 5 is what?
15.
Minus 5.
10.
So this is 5 plus square root of 10, right? And this is what?
5.
And they're not the same, right? So my solution is what?
10.
10. Now, this is how you want to get a better grade on the exam. But this is not mathematics. We did not solve anything, right?
Right.
Let's do the mathematics. X equals 5 plus square root of 3x minus what? 5. What are you going to do when you solve radical equation? What is, again, one more time, what is the first step?
Square.
Isolate the what?
Square.
Look, pay attention to a principle in math. When I say solving for x, we say we're going to isolate what?
X.
X. When I say solve absolute value equations, first we isolate the what? The absolute value. When I say solve radicals, first we isolate the what? The radical. Whatever you're solving for, the general equation, first you isolate the general equation, then we do what? Other steps. So, in order for me to get this by itself, I'm going to go ahead and transpose 5 to where? To the left. So what is the opposite of 5? Negative 5. So now what do I have? I have x minus 5, right? Equal to square root of 3x minus what? 5, right? Now, how do I get rid of that square root? To what power? Second power. And this is going to be to what power? Second. Okay? Now what? Now what do you have on the left side? X minus 5 what?
Squared.
A classic mistake. Pay attention. That's what a lot of students do. X what?
Squared.
Minus 5 squared is what? You know better, don't you? Actually, there's a formula for the binomial. But let's say you forgot the formula, okay? This is x minus 5 times what? All you have to do is do the multiplication, right?
1.5.
X times x is what?
X squared.
Then minus what?
5x.
And then what?
5x minus 5x.
And then plus what?
25.
So what's my answer? X squared minus what?
10x
Plus what?
25.
You see, that is very different than what you wrote before, right? So the left side is x squared minus what? 10x plus what? Equal to, what is, I'm going to be very impressed if somebody tells you what that is.
3x minus 5.
Alright? Square root of a squared is absolute value of what?
Itself.
A. It's not only A. Right? For example, square root of negative 3 squared. What is negative 3 to the second power?
It's positive 9.
Positive 9. But you can't write the answer as negative what? You have to write the answer as the absolute value of what?
Negative 3.
Which is? This is just to guarantee that the answer is what? Positive. Okay. But, in this case, let's say for example, because you want to build a quadratic equation, 3x goes over here, and minus 5 goes over here. What's the opposite of 3x?
Negative 3x.
What's the opposite of negative 5?
Positive 5.
Okay, then what's left on this side?
Nothing.
Okay, then what happened here? Minus what?
13x.
And then plus what?
20.
Hmm?
The 30.
Equal to what? 0. So I can solve this using the quadratic what? Formula, or using the sum and what? Okay. That's your sum, and that's your product. What are two numbers? You multiply, they give you 30, and you add, they give you negative 13.
2 and 30.
Huh?
2 and 30.
Negative 10.
And negative what? So this is x minus 10 times what? Equal to what? Okay? So this gives you x minus 10 equal to 0, right? Which means x is equal to what? 10. And this gives you x minus 3 equal to what? Which means x equal to what? Okay, let's pay attention. Am I done? That's it? Or do I verify my answer? I check your, and if you check your answer, you're going to see that 10 works, but 3 does not work. Okay?
Could you go back over this one on this side? I'm sorry.
Go ahead. What's
When
your
you
question?
said x squared minus 13 plus
Uh-huh.
13x plus 30.
Uh-huh.
When you came down here, you just break them down.
This is equal to 0, right?
Right.
How do you factor this? Remember, the middle term is always your sum, right?
Right.
And this one is always your what?
Right.
So what you're looking for is two numbers, right?
Right.
If you multiply them, you get what?
30.
And if you add them, you get what?
30.
The multiplication is positive, right? So that tells you the two numbers have the same sign.
Right.
They both have to be positive or what?
Negative.
Negative. But the sum is what?
Negative.
So they both have to be what?
Negative.
Negative.
I'm sorry.
And go ahead and tell me some of the factors of 3. Well, you have 10 and what?
10 and 3.
You have also 30 and 1.
31. 50.
Notice that 10 and 3, if you add them together, gives you what?
13.
But we need to tweak it a little bit, right?
Right.
Because what I'm looking for is what?
Negative.
So instead of 10 and 3, I use negative 10 and negative what?
3.
Which still, if you multiply, gets you what?
Positive. Okay,
No, no problem.
What other way could you factor 30?
15 and
15 and 2? And to get 13, the signs would have to be different. And on the test, you'll probably see the choices, both of these, be 10 and 3, but was that the answer here?
2. No.
Because this one didn't work. So on my test, you cross it out, or you say extraneous. On the test, the correct answer, they'll probably have 10 and 3, and then they'll have only 10. Or you're not even pick only 10 on this one. So just because you always find the answer on there doesn't mean it's right. It's the one you want to pick.
See, in here, for example, they give you multiple choice, right? Turns out that only B is the correct answer, right? If this question was given in an open-ended test, it's much better. This question is much better suited for open-ended than multiple choice. Because it gives you an opportunity to explain all this, right?
Right.
Which I'm sure all of you really should have.
It gives your teacher an opportunity for partial credit.
Yes, that's very true.
Mhm.
That's very true.
And it's not that way on this multiple choice.
Mhm.
So you would just answer the X10.
Yes, there's only 10. So that was B.
And B.
You could box it in, you box it or cross that out or say extraneous or something.
Rejected, extraneous, outside the domain, whatever you like.
No solution.
No, I mean, we have a solution, it's just
Well-
this. This one is rejected.
Right, and if they were both extraneous, you would say no solution.
Yeah.
But just in this case, we did get one solution. Questions on that? Question?
They also have, for example, number 22 deals also with the letter. 3 square root of 2 plus 3 all of it squared. Okay? Number 23 also deals with division of the letter of 48. Okay? Let's see what the also number 31. For some reason, a lot of the problems deal with what? Right. This is a classic what? Multiplication, right? First you write it out, right? How's that? What are you going to write out?
What kind of multiplication is that?
Well,
Boil. Now through with this one.
Okay? Go ahead and multiply on your own. I want to see if you can get the right answer. Multiply, simplify, do what you need to do.
I always tell my students, this is the one thing I want them to remember when they go to college algebra. You don't just bring that 2 in, you've got to do what I did out here. Boil it.
That's very true.
Don't remember anything else, I'll be happy. What can you multiply here? Things on the outside, multiply together, things on the inside, multiply together.
So your first term will be what?
no, square root of 4. No, square root of 4.
9 square root of what? That's it, step by step.
9 times square root of
And
2.
then this will be 9 square root of what?
2.
And then this will be what?
9 times square root of 2.
And then the last one, which is
9.
9. Now what? Square root of 4 is what? 9 times 2 is what?
18.
18 plus 9 is what?
27.
And then, what is 9 square root of 2 plus 9 square root of 2?
18 square root of 2. 18 square root of 2.
It's just distributive property and then combination of like what? And you see the student in college algebra. That's one of the classic mistakes on their finals.
Question? The 27? What's square root of 4? So he did 9 times 2 is 18. So that's just an 18, just a regular old 18. And then what do we have over here? Regular old 9. So they're like terms. So 18 plus 9. Okay. And then when you've got the square roots, the radicals here, you treat that like a unit, like an x. You've got so many apples, you've got 9 apples and 9 apples, you've got 18 apples. You've got 9 square roots of 2 and 9 square roots of 2, you've got 18 square roots of 2. So these were like terms, these were like terms. Once you change the square root of 4 to 2. Right?
No way for that.
Let's talk a little bit about number 23, which is division, right?
Can y'all go over that again?
The whole problem?
Yeah.
No problem.
Okay, thank
And show more stuff.
Oh, no problem. What was that? Plus 2,
We'll show the
right?
steps and
you.
stuff.
Oh,
Plus 3.
plus 3. So how are you going to break this down?
Yes.
Go ahead.
You FOIL it, so 3 square root of 2.
You want you to write it down first, so you see it in front of you. I would write it down always. Don't try to do it in your head, because that's when you make your mistake.
You're right.
Okay, plus 3. 3 square root of the 2 plus 3.
Yep. So now what are you going to do?
You multiply the 3 times the 3 on the other.
Uh-huh. So this term is going to multiply this term, right? How is that? Tell me.
3 times 3?
Which
Yes.
is,
9.
and then what?
2 times 2?
But the 2 is underneath the radical, right? And this 2 is also underneath the what?
The radical.
So the result is going to be underneath the what?
The radical.
Okay? Now, 3 square root of 2 is going to multiply what?
It's
Right.
right. Oh, right, yeah.
Okay? Now, this 3 is outside, right?
Right.
This 3 is also what?
Outside.
Outside. So 3 times 3 is what?
9.
9. But 9 of what? 9 what? Square root of what? Is that the step that you're not clear on?
Mm-hmm.
Okay. Let's go right on the side. This is 3 square root of what?
2.
Oh. Okay. Go ahead. 3 square root of 2.
What will be, okay, it was like 3x times 3. What if you had 3x times 3?
What would you do in this case?
What's 3x times 3?
3x times 2.
3x times 3.
Oh, times 3. 9x.
9x.
Okay.
You multiply the 3's, and you just had to keep the x. It is multiplied, but you just put them together. Nothing to do but write it down. Same thing there.
So here you have, with the same analogy, you have 3 square root of 2 times 3, right?
Mm-hmm.
So this plays the role of x, right? 3 times 3 is what?
9.
And then instead of x, we put square root of what?
2.
2. Is that better a little bit now?
Oh, yes.
Okay,
Uh-huh.
sure.
Or think of it as inches. If you have 3 inches, but you want to do that 3 times,
Mm-hmm.
3 inches, 3 inches, 3 inches,
Okay.
it'd be 9 inches. So treat it like a unit.
Is that good? Now this also is the same. 3 is going to multiply 3 square root of 2. So you have 3 times what? Which is 9. But then what are you going to do with this square root of 2? Just what?
Bring it down.
Right. And then the last one, which is 3 times what? Which is 9. Now we're going to do step by step. We're not going to skip anything. Square root of 4 is what? 2. So 9 times 2 is what?
18.
18. Plus, these two can be combined together, right?
Yep.
Yeah.
It's going to be what now? 18 what?
Square root of 2.
And then plus what?
9.
Okay. Now what is 18 plus 9?
27.
27. Plus what?
18 square root of 2.
Square root of what? 2. Is that better?
Yes, yes, that's better.
Definitely.
Right.
Anything for you, Charmaine?
Love it, love it.
Okay.
One of the students Thursday said, well, you can make it easier but by doing it this way. If it helps you to line up your like terms and go down the page, apparently one of the teachers is showing it that way, and that's really good. And then it was easier for them, so, yes.
What would happen if we have a multiplication of two radicands in a parenthesis, and outside the parenthesis, just a number, just one real number?
Okay, you want to give me an example, like what you're talking about?
Like 3,
On the outside?
yeah, on the outside, parenthesis, and two radicands.
Two
With numbers on
square
the
root
outside too,
3
in
times-
addition.
Oh,
Okay.
adding?
Yeah.
Okay.
That's what he meant. Yeah. That's
So
it.
that number in the outside will be treated as multiplication by the outside number with
Yes.
the parentheses?
You got to distribute, and yes, pay attention, is it inside or outside of a radical? It's outside. So it can only be multiplied by the 2. 3 times 2 is 6. But it's still got that square root of 3. And 3 times 4 is, but it's still times that square root of 5.
You can't add them because they don't have the same radical.
Right, when you're adding, it's just like with adding an x and an x squared. They're kind of alike, but are they exactly the same? You have to leave it that way. You have to leave that way. Okay. And if it had been square root of 3, then you would combine them.
Thank you.
Radicals have to be the same, both square roots. We didn't do cube roots in this book. In the old book, you had to do cube roots, and y'all like that, did But and also the radicand, the thing under the radical has to be the same. If you're adding, not if you're multiplying.
What about if you have something like this? What would you do?
That will be in number 1 outside the radical sign, in the within the parentheses.
It's like an
So
imaginary.
that would be 3 times 1.
So that would be your what? This would be what? 3 times
Yeah.
square root of 8.
Square root of 2.
And then 3 times 1 again, which is 3 square root of what? 5. You see that? But in any case, what is very important is for you to never mix the numbers outside with the number what? Inside the what? The radical.
You're trying to do the rationalized in the denominator.
Yeah, what was that? 3
3
square root of 40 what?
8.
Well, its basic idea, what do you want to do here?
You want to get rid of the radical.
Simplify the square root of what?
48.
If you can. So what is the square root of 48? That? 16 and what? 3. What is the square root of 16?
4.
Square root of what? 3. So I can replace that square root of 48 with 4 square root of what? 3. So now what? Multiply by what? By
What's the rule? We can't have what? You cannot have a radical on the bottom, the denominator.
this is your problem, right? This is, so I'm going to multiply by square root of what?
3.
And then square root of what? 3. Because they will help me get rid of the radical in the denominator, right? Okay, so now what? That's how do we multiply a fraction? We multiply across, right? Numerators and what? 3 and what?
Square root of 3.
And this is 4 square root of what? 9,
9.
right? So how does that help? This is 3 square root of 3 and 4. What is the square root of 9?
3.
Times 3. So now what? 3 and 3 do what? What happened to 3 and 3? So what's my final answer?
Square root of
Over what?
4.
do we have a radical in the denominator? Are we done?
Yes.
Anybody has any question about it? Go ahead.
Yeah, that bottom part.
This?
Uh-huh. Yeah.
So you understand up to this point,
Mm-hmm.
but the last, okay.
Do you understand why we're multiplying by square root of 3?
Yes.
Okay, what is square root of 3 over square root of 3? What's square root of 3 divided by square root of 1? So we're really just multiplying by 1. Remember, we're just changing the way it looks, not the actual value.
This is 1, right? When you multiply by 1 is identity element. Nothing changes, right? But are you talking about the simplification? Like how do we simplify?
Mm-hmm. Yes.
Okay, what is 3 over 3? They can cancel because 1 is in the numerator, 1 is in the what? Denominator. So what is left? In the numerator, square root of what?
3.
And the denominator is what?
4.
4. That's exactly the step that we did.
Oh. Okay. Now I'm.
Yeah, if you wanted to go ahead and multiply it. What are you saying? This is 12, and then you reduce it.
Oh.
We're going with the
Is that good?
reducing your 12. We just reduce
Oh, okay, that's easier, yes, love it.
it. But it's harder, but if it makes more sense to you, that's fine. She understood it better when she multiplied the 4 by 3 and got the 12.
Oh, okay.
And then
I mean,
See,
yeah.
use one of
So you multiply the 4 times 3 is 12, right? And then 3 over 12 you simplify, right?
Right.
Yeah, that's fine too.
So he's just reducing the fraction, that's what he's doing.
I'll tell you what, why don't you go ahead and try this on your own. 3 over square root of 12. See what you can do. Okay? And it's understandable that a lot of you have questions about radicals because that's one of the last chapters you do in this, in 0310, right?
And you don't have to simplify that radical on the bottom first, but it makes life easier. That's why I did that. Y'all like to do easy, right? Anybody like to do it the hard way?
Uh-oh.
Over your chair.
Oh, gosh. Oh, yeah, yeah. No wonder I've had the
Cookies
reason.
and candy back here if anybody's getting hungry.
Oh, Lord.
Go off.
Lord.
Anybody want a cookie?
You got it? You want to come and show all of us how you do that? Okay, well, go ahead and tell me what you did.
I did exactly how you showed
Uh-huh.
me to do the other one.
So you simplify square root of 12
Oh, yes, and
by doing what?
3 times
4 times what? So this came out to be 2.
Anybody else hungry?
So,
I multiplied that, by,
Hungry people on this side?
and then I got, 3 square root of 3 over 2 square root of 9. And I simplified the square root of 9, and I got 2 times 3. And I canceled out the 3s, and I got square root of 3 over 2.
that is just beautiful.
That's right.
I get the difference in that. I multiplied that 12 by 3, but square root of 12 by 3.
Can you show me what you're talking about? Go ahead.
Sorry.
Yeah, that's fine. Let me show you.
With the numeration, what you need.
I write down one, okay? 3 square root of 12. What he did, he multiplies it by square root of 3 over square root of what?
3.
Oh, he went down into
Yeah. Then you say this is 3 square root of 3, and this is square root. 12 times 3 is what?
36.
And then 3 square root of 3 over what? This is what?
6.
And this is square root of 3 over what? 2. Okay, now you realize that this worked for you because the square root of 12 actually simplifies to do what? To 2 square root of what? 3, right? Okay.
If you didn't want to
But you're saying it's not gonna work all the time?
Depends on the problem. What I'm saying here, it's a good thing here, you notice that 12 times 3 came up to be what? 36. Well, that's excellent. That's a good observation. That's very smart. But it might not work for different problems. You see what I'm saying? The only reason this worked for you is because this square root of 12 simplified to 2 square root of 3. So when you multiply by square root of 3, actually, this simplified to 3. And 2 times 3 is what? 6. Okay?
That's great. To make it harder, you could have left it like this and multiplied top and bottom by the square root of 12. What would we have gotten here?
3 times square root of 12 over 12.
12 times 12,
144.
144, so it makes it a bigger number. But if you recognize 144 as a perfect square, which it is, we just saw 12 times 12, what are we going to get on the bottom? Square root of 12. Good. And then simplify it and right back.
Oh.
Go ahead.
Okay, the way
Well, we need to
we
simplify.
were
this
shown in
into-
the class was to take the, like she has it over there, the square root of 12 over the square root of 12. But when you do that, it's actually 12, which saves you a step of having to do the 144. Because
Yeah.
it is a square root.
Yes,
You just take it
this
out of the
way is
square
better.
root.
You are correct.
Yes.
You are correct.
So you've got a harder thing to simplify here, so I would definitely simplify first, but you don't have to, if it's still working.
Yeah.
But we like to do things easy.
Yeah. And pay attention to something. Like all of you are going to hopefully take college algebra, right? What's the idea here? If they give you a problem in college algebra that has, let's say, 15 steps, you cannot afford not to simplify because you're going to be wasting a lot of critical time. That's why we always want to encourage you to do what? Simplify the easy way, the standard way, because if the problem is, this could be only one step in the college algebra problem. You see what I'm saying? But that's very smart what you did. It's a good observation. All right. Is that enough about radicals? Yeah, you all had enough?
You getting tired, you okay?
No, I'm good, I'm good. Let's do number 3, which is word problems. I know that's like your favorite. All of you love word problems. Okay? What I want you to do is read the problem, and I want you to only highlight or underline the information that you think important. That's important to the problem. Okay?
Number 3. First page. What's the first thing you did? Draw a picture. They don't have a picture, draw a picture. It needs one.
All right. What's the important information here? Well, it's important to know it's a rectangle, right?
Mm-hmm.
What else?
Like the length is 8 meters longer.
Mm-hmm. And then what else? And the perimeter, right? Now pay attention. I want you to translate this to mathematics. For the length, I'm going to use L. And for the width, I'm going to use W. Translate what he's saying to mathematics.
Start with the
2W plus 1
Well,
equal to what? Equal to 160 or equal to L?
Equal to L.
L. First of all, does anybody not know how to translate this? That's key. All right. Let me ask you a question. Which is easier to deal with, one variable or two variables? One variable. We have a W and a what? Okay. But instead of L, I'm going to replace L with what? With what? What can I replace L with?
2W plus 8.
Plus 8. And here's going to be 2W plus what? And here's going to be also what? I mean, the width is going to be only what? W. So, we have used that translation to reduce those two variables to only how many? One. Then what else does he give you? What kind of information? The perimeter is equal to what?
160.
Remind me, what is the perimeter? Is that the outside?
Outside.
Or that's the outside, right? So this is what I'm going to do. 160, right? Equal. If that's the outside, what is this?
Inside.
No, I mean, what's the value of this side?
Unknown.
Unknown.
Which is?
W.
W. Plus. What's this side? Plus. Plus what? Plus. Okay. This will let me solve for what? For what?
what's the only variables.
For the width. That's okay. Now you see the strategy that we were talking about before, or lining up things? We can do this here also. Let's line up. This is what? W, right? And this is what? 2 what?
2W.
And this is what?
W.
And this is what? 2W. How many W do we have in total?
4.
Count them up. Adam's
6 or 4?
6.
Remember, this is 1 W, right?
Right.
So we have 6 what? Okay. What is this? Positive what?
8.
8.
And what is this?
Positive 8.
Which is? 60. So what do I have? 160 or 6W plus 16 equal to 100 and what? 60, right? So now how do I solve for W? Subtract what?
16.
Okay? So this is going to be negative what? 16, right? So 6W equal, what is 160 minus 16? 1 what?
44.
Okay? So, how do I get rid of that 6? Divide by what? Okay? So what is W equal to? Am I done? That's all? No, that's all I care about, W? That's it? What do I do now?
You have to add 8 to it.
So the length's going to be 2 times, what am I going to replace W with?
24.
24 plus what?
8.
Okay, what is 2 times 24?
48.
Plus 8? 56. So what's my answer here? For the W is what?
24.
And the length is what?
56.
56. Okay?
Answer A.
Okay.
On the test, they'll probably just ask for just the length or just the width. Make sure you found the right one. Don't say the width is 56. Pay attention to the question.
Now, is your final exam multiple choice or open-ended?
Multiple choice.
Also, we shouldn't mention this, but we do anyway. If it's multiple choice, you can go back and do what? Backward substitution.
Substitution.
Remember, that's not mathematics, but it will help you solve the problem on the test. Okay? in any word problems, you want to use VES. V is how you select your what? Select your what?
Variable.
Variable. For example, in this problem, it wasn't difficult for you to select the variables because he already gave you. The width is W and the length is what? L. Right? E is how you set up your what?
Equation.
Equation. This is the step that most of us have problems with, right? And S is how you what?
Solve.
Solve and check. Okay? If I were you, I would divide every word problem in 3 parts. First, I select my variables. Then I set up my equation, which is easier said than done. Then you do what? Solve and check. Is my answer reasonable? Selecting a variable usually is not hard. This you can select from the actual question itself. For example, here he's asking you for the length and the width, so you know the variables are going to be length and what? This is hard because this demands that you know a lot of what? Translation word skills, right? Okay. Now let's see. Okay. I just want you to translate the following sentence. See how many of you are going to translate this one right. Length is 5 less than 6 times the width. Go ahead. Translate this.
And L equals 6W minus 5.
You are just 6W minus what?
5.
One of the classic mistakes, people, what do? Some of you, not you, not you. 5W minus what?
6.
You're not going to do that, are you? This is 5. We are taking 5 from 6 what? Just be careful, okay? They might give you something like that on the test. I have no idea. I love to do this problem with my students. And you see most, maybe 10% make that mistake. All right. Also, you have number 19 as a word problem related to what? I think system of linear equations. Do you have anyone about distance? Do you? Yeah, number 21. All right. How about distance? Okay. Let's try to see if we can set up those 2 problems. Number 19 and 21. Okay? Okay. What I want you to do in number 19, I want you to first tell me how you're going to select your variable. Okay? So how do you select the variables? What is the actual question? What is he asking you? How many what? How many bracelets and how many what? Remember, selecting the variable is from the question itself. So we're going to call the bracelets X. That's the number of bracelets. And the necklaces was Y. Okay. So I'm looking for 2 things, right? And he's going to give you 2 conditions to use. Okay? Now if you... What's the first condition that we can use to relate X and Y?
The price of them?
The price. Okay, what is the price of each bracelet?
$5.
So 5 is associated with what?
X.
Okay, what is the price of each necklace?
$7.
So 7 is associated with what?
Y.
So if I add this, I'm going to have the total what? Price, right?
Right.
Which is what?
780.
So my first equation is 5x plus 7y is equal to what?
780.
780. Okay? And how else I can connect x and y?
X plus y.
By the what?
Quantities.
That's just x. X plus y is what?
120.
Is 100 and what? 20. You see, this is how you selected your variables, and this is how you set up your what? Equation. Now what is left is the solving part, right? But once you have this, and if it's multiple choice, again, you can go ahead and do backward work. But that's not a good idea if it's open work, and you have to solve the problem.
They usually just have one of the answers on there.
Yeah, if, for example, if they ask you for x or for y, like here, for example, what is it that they are asking you?
How many
This one they're
bracelets?
asking
How many
for
rings?
both.
Yeah, they're asking you for both, right?
Right.
No, just, yeah, but
Yeah.
usually they'll just ask for bracelets or necklaces.
Yeah. But if they ask for x or for y, what you can do is eliminate the variable they are not asking for, right? For example, let us say they are asking only for y, which is the number of what? Necklaces. I can definitely eliminate what? How is that? How do I make these two what? Opposites. How do I do that?
By negative
Negative 5.
5.
I can multiply this by -5, right? This will eliminate what? X, which is the number of what?
Bracelets.
And then you can get the number of what? Necklaces. That's in case they're asking you for one, right? Yeah.
I'd still get both and plug it in and check. Both equations.
I have a suggestion for you. On Wednesday evening, if you want, we can ask Miss Allison, since I have tutorial again, if we can continue in the review session. If all of you, on Monday I mean. Because you don't take the final on Monday, do you? How many of you take the final on
We'll be taking
Monday?
it Monday and Tuesday.
Yeah, some of you take it on Monday, huh?
They need to retake some Wednesday and Thursday.
In any case, for those of you who don't take it on Monday, you can always come and ask more questions, right? You want me to solve this problem, or can we do some more word problem just for the sake of time? And let's try to set up the distance problem, just for the sake of time.
Can you finish solving that, Mr. Osmond?
Okay.
Oh.
Okay. So, let's say we want to solve it, okay? What do you do? If you want to use elimination, right? Or we can use substitution. It's up to you what you want to do. Substitution is what you would do? Okay, how would you do that?
I would plug in, let's see, A is 30 bracelets and 90 necklaces. I would plug in 30 for X and 90 for Y, and if it equals 780, then it's true.
Yeah, but in this case, what you are doing is smart, but you are verifying, right? You are just, but what we're saying, how we solve it, how do we solve it? You see that? What you're doing is very smart because they gave you the answer choices. But how do we solve it using substitution?
Remember on the test, they'll probably only give you one of the answers.
Mhm.
We said
So
one
you
of
won't
the
be able to do
equations,
that.
like x plus y,
Check it
y
out.
equals, we solve for y.
Okay, let's do that. So let's say this is equation 1, and this is equation what? 2. So you're going to use equation 2 to do what? Solve for y. Let's do that. So we have x plus y equal to 100 and what? 20. So y will be equal to what? 120. This x is going to be transposed, will be minus what? X. And this can be what? Substituted in the what? In the first equation, right? So I'm going to just box my answer over here. In the first equation you have 5x plus what? Plus 7 what?
times 120.
Equal to what? 780, right? So 5 x plus 7 times, what will I do here? Replace y with what?
120 minus X.
120 minus what? Equal to what?
78.
70. So let's go ahead and do the what? Multiplication. What is 7 times 120? 7 times 0 is 0. 7 times 2 is 14. And 7 times 1 is...
840.
Huh?
840.
Is that true?
Mhm.
Okay. Minus what?
7X.
Equal to what?
7.
Now what do you want to do?
Combine that term.
Okay. And what is 5x minus 7x?
Yeah, 2x.
Plus what? Equal to what? 70. Now what? Subtract what?
40,
Subtract 840. Negative 840.
negative 60.
So what do you have here? Negative 2x equal to what?
Negative 60.
Negative 60. So now what do you do?
We're going to divide it by negative
Divide by
2.
negative 2.
Divide by negative 2, divide by negative 2. So what do you have? X equal to what?
30.
So am I done?
No.
How am I going to get y?
You're going to plug.
Substitute. Substitute. All right, everybody want to plug 3? Minus 30, which is what? Y equal to what?
90.
90. So I'm going to have 30 bracelets and what?
90.
90 what? Necklaces, right? Is that okay, Shami?
Why is that, oh, you brought that too. Why is that too negative?
Oh, this is 5x, right? Minus what?
Oh.
7x, right?
7x, yes.
The distance?
You could take them to the lab.
Yeah, certainly. What?
You're still hearing.
So here's one suggestion. We're going to do one more word problem, the distance word problem. Then all of us can go to the lab and we can continue over there in the lab if there are no people, right? How many of you want to do that?
How many can stay longer?
Yeah.
So we'll be starting 3:20 in here at next.
Yeah.
What time, did they say 11 or 10:50? 11?
Got it started.
So he can keep going till 11. You can keep going till 11. Thank you.
Right. So let's go ahead and do the last word problem, which is, what was that? What number?
21.
21? Sorry.
320 can listen to this because
I'm sorry?
they can, we got some 320, they can listen too because we have the same.
Yeah, I
problem.
mean, this is the same concept, right? A twin-engine aircraft can fly what? 1,400 miles from city A to city what? B in 5 hours. So the distance is what?
1,400.
1,400, right? Miles. And the trip is from city A to city what? Then the time is what?
5 hours.
5 hours. All right. But this trip is going with the what?
Wind.
That's very important. This is with the what? Wind. So, let's divide this into a table, right? This is the going and this is the what? Return, whatever you want to call it. That's not important. Okay? Distance, rate, and the what? Time. No. So on the going trip, he's going with the what?
Wind.
Wind. So is the wind helping your movement or hindering your movement?
Okay.
Helping. The distance is 1,400 miles, right? The rate, he didn't say anything. The time is what?
5 hours.
5 hours. That's all we know, right? What about on the return trip? What happened?
Same distance, it takes 7 hours.
Same distance, but now we are going against the what? So naturally speaking, he's going to take more time or less time?
4.
More, right? So what's the time here? 7 what?
Hours.
Hours. Now, let's you and I have an intelligent discussion about this problem. Look, You gotta be a smart word problem solver. You can't, he's not gonna ask you about the what?
Just
He's also not gonna ask you about the time.
time.
He's gonna ask you about the what?
Right.
Rate. But talking about the rates, we have two rates, right? The rate of the what?
Going
Going
with the wind and then against the wind.
So the rate of the airplane and the rate of the what?
Wind.
Wind. Right? Now, let's see what he's asking. What is the speed of the what? Wind.
Read the question on the
What is the speed of the wind?
Yes.
end. That's the end.
No.
Okay, but you need to know the wind and,
And the aircraft, right?
It is the first speed of the wind.
Yes. How would you do? But remember, the aircraft is going with the wind and against the what? So, the speed of the aircraft and the speed of the wind, they are related, right?
Exactly.
Let's say the speed of the aircraft was x. That's the speed of the plane, of the aircraft. And the wind has a rate of what? What? When you are going with the wind, what are we going to do with those two rates? Add it, because we are, it's like a cumulative vector. X plus what? Y. And when you are going against, what are you going to do? So this is going to be x minus what? Y. Okay? So now what happened? Over here. Distance equal rate times what? So 1400 equal x plus y times what? 5. Now, from the very beginning, make your life easier. I can divide here by what? And divide here by what? So what do I have? X plus y is equal to what?
280.
1400 divided by 5, which is?
280.
280. That's the first equation, right? From this trick, you have also 1400 equal to what? X minus y times what?
780.
What am I going to do now? Divide each side by what?
7,
Okay,
200.
let's go ahead and do that. Then what happens? Now you have x minus y equal to what?
200.
200. How am I going to solve this system right now? How am I going to solve this system? X plus y is equal to, what was it? 280? And x minus y is equal to what?
200.
200. What is a very effective way of solving this system?
Elimination.
Elimination. Actually, they are opposite, right? Let's go ahead and add. Now you get 2x equal to what? 400 and what? 80. So x by itself is what? 200 and what? 40. That is the speed of the aircraft. 240 miles per hour. What's the speed of the wind in this case? Y is equal to what? Only what? 80, right? Because if you add them, you're going to get 200 and what? 80. Now pay attention to something. In physics, this is a stupid problem. It's not realistic. Nobody's going to go against a wind speed of 80 miles per hour. Especially if your aircraft has only a speed of 200 and what? 40. That is certainly not realistic at all. Okay?
Okay. Where are you getting the 240? Oh, because it's just.
Oh, because we divided by 2, right?
That's right.
We divide by 2, right?
Right.
So, go ahead and take all your materials or your equipment to the lab. We're going to finish this review together. Thank you all for being a good class. We continue. Yeah, you can keep it. We're going to continue doing all those problems. I'll probably finish the whole review one at a time. We'll just move to the lab.
What's with this?
Oh, Miss Allison said they are filming the review because they want to show it to us.
Is it staying here?
Yeah, it's okay.
Turn in your balloons here before you go.
I walked and got it. Well, he ain't no toothbrush or nothing like that, so yeah, I went ahead and got it. Oh, really? Really? Oh. I didn't feel like that.
Where you going to go? I don't want to feel a little bit. I was gonna ask her, we got
How many mistakes this one doesn't make on that? That's what she did.
Okay, I don't know this room, you may have to go to another room.
I might come on that.
Did it in the paper? Okay, did everybody sign in? Let's see if you get it, some people can bring up it. Okay. Back here, we'll start passing around. I've got, an evaluation and a worksheet.